Welcome to this series of videos on liquefied petroleum gas. Now in this first episode we're going to be looking at first the characteristics of the gas, and second we're going to be looking at the installation of these things. So this is a storage tank and we're also looking at bottles. So let's get on with it and find out exactly what all these characteristics are. Let's have a look at the characteristics of LPG and compare it with natural gas. So first of all, LPG stands for liquefied petroleum gas. So it's a liquid in its normal state and we draw off the gas vapours. Its chemical formula C3H8. Unlike natural gas, which is CH4, which is mainly methane. I ain't going to say what that chemical formula is. I might put it at the bottom, it's a bit long. Anyway, I just can't see it. Now, its origins, 60% of it is from extraction from when we do natural gas. So when we're drawing natural gas out of the ground, there's also LPG there. So it's from the old coal fields. 40% of it is produced during the refining of crude oil. So it's a byproduct of crude oil as well. Now, its density, that's the big thing. So it's 1.5 times heavier than air, unlike natural gas, which is lighter than air. So natural gas, if you had a gas leak, would fly away, unlike LPG, which would lie low, which can cause some major problems. So you might not be smelling it because it's down there at the bottom and it's hard to get rid of. So there's no way we would be putting this LPG boiler in a cellar. LPG is odourless and colourless, the same as natural gas, and it has a mere caption added to give you that smell of rotten eggs, the same as natural gas. Its explosive limits though, 5 to 15% for gas in air for natural gas, but we've got 2.1 to 9.5 gas in air for LPG, so the lower explosive limits are a lot lower. It's also ignition temperature is 410 to 580. But the auto ignition temperature for natural gas is slightly higher than LPG, it's about 760 degrees C. Propane boils at minus 42 degrees C. That means it turns into a gas, and that's what we're drawing off this gas, and it freezes at minus 188 degrees C, which is a bit lower, well, a bit higher. You need natural gas free anyway. The combustion formula for LPG is C3H3 plus 5O2 equals 3CO2 to 4H2O. So let's have a look at a few more. Now, last few before you all fall asleep, I promise. So we know between natural gas and LPG, relative density for natural gas is 0.6, and we know LPG is between 1.5 and 2. So we know it's heavier than natural gas and heavier than air. So the gross calorific value for natural gas is 38.76 megajoules per meters cubed, and for LPG it's 93.8 megajoules per meters cubed. Flammability limits we know is 5 to 15% and around about 2 to 10 for LPG. Flame speed 0.36 meters per second for natural gas, 0.46 meters per second for LPG. Ignition temperature we said 700 degrees C for natural gas, 530 degrees C for LPG. Wobby number between 48.2 and 53.2 for natural gas, and 72.6 to 87.8 for LPG. So Wobby number, what is it? Well, the Wobby number is basically a number given to a certain type of burner giving or using a certain type of gas, and it uses its calorific value, its relative density, its flame speed and other matters what come into it. So the way you calculate the Wobby number is, it's calculated by dividing the calorific value of the gas by the square root of the relative density. So I've done a little calculation for you. For natural gas, 38.76 divided by 0.77459 is around about 50, and for LPG 93.8 divided by 1.22474 gives us 76.5 for those particular gases, which falls within those parameters. So that's some information on the combustion for LPG differently to natural gas. Now, if you're looking for a training manual to go along with these videos, why don't you check out Viper Gas? So they produce a hard copy like this one, or you can download the app and you can get this direct to your smartphone. So I will put in the description down below all the information you require to get in touch with Viper Gas. So that's the characteristics of the gas. Shall we have a look at this cylinder first and see exactly how they should be installed and what they're made up of? Tanks come in many different sizes, and they are sized normally by how many litres of water they hold. The size of the tank also determines the heat input in kilowatts for the appliances. So depending on the size of the tank will depend on how many kilowatts you can have feeding from the tank. Now first, let's have a look at this actual tank positioning. So there should be a minimum distance called the tank separational distance between the tank and any buildings or the boundary line or fixed source of ignition. So from the drawing here you can see the tank needs to be 3 meters away from the building, and it needs to be 3 meters away from any garage, and also 1.5 meters away from any source of power cables going over the top. You can also see the road which is passing at the side of this tank needs to be a minimum of 2.75 meters wide, and that's so the actual tanker can pass up the side of the tank without damaging it. Also, the tank can actually have a boundary wall put around it, but not on all 4 sides. Vessels should be sighted so that when they are being filled, the tanker driver can see both the connection of the tanker and at the storage vessel. The route of the hose from the tanker to the storage tank should ensure that the hose will not pass through any buildings or go over any walls or hedges. If you're struggling for the dimensions above the ground, Keller tanks can also be buried underground. The siting requirements for bulk storage tanks is covered in Liquid Gas UK Code of Practice 1, formerly UK LPG Code of Practice 1. In case of a leak or leaks, there should be plenty of room around the tank to ensure that there is good airflow so that the pockets of the heavier than air LPG vapours cannot build up around them. It is also very important to keep the area around the tank free from rubbish, especially if the rubbish is combustible, and it could also reduce the levels of ventilation around the tank. For similar reasons, keep weeds and grass down from around the tank. If you choose to use a weed killer, make sure the weed killer doesn't dry out the weeds, because this will make the dead plants easier to ignite. So let's have a look under this locked cover, because all these tanks require a locked cover. So the first thing we can see here, so this valve is the fill valve for Keller. So they take this top off here, connect onto the tanker, and they can fill the tank that way. The red knob we've got here is our ECV. So we can turn our gas off with here. It also tells us on this little notice here that we can turn the red knob to turn off. Then the first thing we've got here is our first stage regulator. This reduces the storage pressure of around 6.9 bar or 100 psi to 75 millibars or 0.75 bar. It then goes via this 10mm pipe to our overpressure, underpressure second stage regulator. So we've got our reset mechanism. This here with the sender unit on for our gauge is our pressure relief valve. The pressure relief valve works by The valve is held in a closed position by the force of a powerful spring. As long as the pressure inside the tank is less than that of the spring, the valve will remain closed. If the pressure in the tank rises significantly higher than the spring can withhold, the valve will open, resulting in a hissing sound outside the tank. If the pressure in the tank rises significantly higher than that of the spring, then the valve will fully open. It initially makes a loud pop, followed by a blast of released propane gas. Once the pressure is released and the tank pressure falls below that of the spring, the valve will automatically close. This ensures that the vessel is protected against an overpressure situation. These PRVs are designed to discharge to atmosphere without impinging on the tank or any ancillary pipework or fittings at 120% of the tank's maximum design pressure of 14.5 bar. And then this is the gauge which tells us how full or how empty our tank is. So this signal is sent to Cala, so if they notice we're getting too low, they could get in touch with us, or we can just ring them up and they'll come and fill it up. So they are the components what we've got on top of this tank. This pipe here going down to the ground is what goes over to the house to feed the boiler. So our pipe work going across the garden is at 37 millibars, our working pressure, not 75 millibars. All LPG bulk storage tanks come with a data plate. The only thing missing on the data plate is actually how much gas is in the cylinder at any one time. This bulk storage tank also requires this warning label stuck to the side, which tells you it's propane, no smoking, no naked flames, that it is flammable, and it also gives you the emergency contact number for if there's any problems. Now let's have a look at a tank where the second stage regulator is separate, so the pipe coming away from the tank is 75 millibars. So inside this tank we've got up to 2 bar, and then you can see from here it's reduced to 75 millibar, which then goes across. So there's your main ECB coming out of your tank, comes across here, that's the test nipple there, and then this pipe is still 75 millibars, which then goes across the road to this valve here. Now this main gas pipe running across this road has to be made of MDPE, medium density polyethylene, to BS-EN 7281 or BS-EN 1152 Part 2. With the revisions to the Liquid Gas UK COP 22 in October 21, the depth requirements for buried pipework were revised. Agricultural land should be a minimum of 1,100 mil, under roadways or grass verges adjacent to a roadway 750 mil, and within the grounds of private property subject to not very heavy traffic 600 mil. Now if you do bury the polyethylene pipework, it must be installed away from the building, and the distance is dependent upon the pressure in it. So if the pressure is greater than 75 millibars, we need to be 3,000 millimeters away from the building. Up to 75 millibars, it's 250 millimeters away from the building. Now there should be a test point here, around here somewhere, after this valve, but there isn't. So this is still 75 millibar in here, which then goes along here, and like I say, across there, which then comes to the second stage regulator, which is around this corner here. And this is the second stage regulator, and this brings it down to 37 millibars here. So built into these second stage tank regulators are what we call the UPSO valve, or under pressure shut-off valve. To reset them, there is a black lever here, or the green in the one we've got. You just pull the lever and it allows the gas on the other side of the diaphragm to allow the gas inside the house when the pressure is dropped for any reason. Then you just put the cover back on and job's done. So there's the second valve. Oh, there's no test nipples. Anyway, this is still 75 millibar here, So there's no test nipples. So if you look on this here, you can see this is where we're reducing it then to the 37 millibars to come into the house as it is now. But no test nipples at all. Only the one on the tank. In large caravan parks you may find multiple cylinders connected together. The area should be protected with signs stating LPG gas storage, no smoking, naked flames. It should also give you the supplier's emergency service number. All compounds require a water supply and dry powder fire extinguishers. If there is a fire, evacuate all persons from the danger area except those required to deal with the emergency. Where the fire is near LPG cylinders, remove them to a safe place provided this can be done without exposing anybody to danger. If any cylinders or tanks cannot be removed, cool them down with water. Always approach any gas fire or gas leak from upwind if it's safe to do so, and be aware of the possibility of jets of flames from the pressure relief valves. Dry powder fire extinguishers are recommended to fight LPG fires if the leak cannot be stopped by operating the cylinder's isolation valve or the tank emergency control valve. Remember, your first action must always be contact the fire brigade on 999 because fires near LPG cylinders or storage tanks may require them to be doused with water for 24 hours after the fire has been put out. This storage compound must be secure from the general public. The storage site must be a level, compact, hard standing. In general, a cast concrete base is best as it prevents weeds growing through and causing low-level ventilation problems. Here you can see the cylinders are joined together with a single header with one first stage regulator sending the gas out to the caravans at 75 millibars. When it reaches the caravan, it goes through a second stage regulator and a gas meter so the individual caravans can be billed. Cylinders come in various sizes and they're measured by their empty weight. So you get a 3.9 kg, a 6 kg, a 13 kg, a 19 kg and a 47 kg. Butane, they come in 4.5 kg, 7 kg and 15 kg. As well as different sizes of bottles, there's also different types of bottles for different applications. There is even a bottle for a gas-powered forklift truck. Butane is stored in specially designed cylinders as a liquid under pressure. Butane is stored at 28 psi or 1.9 bar. 1 volume of liquefied butane gas produces 233 volumes of gas vapor. Propane is also stored in specially designed cylinders as a liquid under pressure. The pressure of propane is 100 psi or 6.8 bar. 1 volume of liquefied propane produces 274 volumes of gas vapor. LPG portable cylinders used for butane and propane in the UK are designed and tested at pressures of 32.1 bar or 474 psi. This is 1/3 of their burst pressure of 96 bar or 1420 psi. Cylinders should be sited in an upright position on a firm level ground to ensure they do not overbalance. A falling cylinder could damage the hoses or pull the regulator from its mounting, causing a gas escape. Cylinders should be located against a wall or fire-resistant structure for support. Cylinders should be sited at least 1 meter when measured in the horizontal plane from any possible source of ignition, combustible material and openings such as doors, windows and ventilation ducts. Cylinders must be sited in well-ventilated areas outdoors. They should be accessible at all times. They should not obstruct thoroughfares. They should be protected from accidental damage by vehicles, animals, and interference by unauthorized persons. They should be secure Because of the way the cylinder is constructed, they are not required to be secured to the building. The foot ring at the base of the cylinder is wide enough to ensure that the cylinder is stable as long as the cylinders are sited on a firm, flat, hard standing. But if you have 4 or more cylinders, it is advisable to secure them to the wall. Where cylinders are installed in an enclosure, it is important to ensure that the enclosure is the adequate size to cover the number of cylinders being used. The enclosure should have a minimum fire resistance of not less than 30 minutes and should comply with BS 476 Part 22, 1987. Cylinder housing ventilation should be provided at high level directly to outside above the cylinder valve, and at low level as low as possible to prevent any build-up of any gas if leaks occurred. Outside enclosure vents should not be less than 1/100th of the floor area of the housing. Cylinders must not be located within 2 meters of an untrapped drain, cellar or gullies. Butane bottles may be used indoors, including flats, as long as they meet the requirements of the building regulations. Only butane cylinders can be used indoors and not propane cylinders. When butane cylinders are sited within a permanent dwelling supplying a fixed installation, they should be located within a housing with a 30-minute fire resistance. Butane should not be used in any premises where the use of mains gas is prohibited. A maximum of no more than 15 kilograms of butane should be stored or in use per unit. But 2 15-kilogram bottles can be stored at a premises at any one time. Do not use LPG barbecues indoors even if they are supplied by butane cylinders. Like the storage tank, the cylinders are pretty much the same. So depending on the size of the cylinder will depend on how many kilowatts it will feed. So a 47 kilogram cylinder will feed 33.86 kilowatts. If you take off more gas than the cylinder can produce, can cause us massive problems. Transforming the liquid propane or butane mixture in a cylinder to the desired gaseous state requires heat. The gas and therefore the LPG cylinder cool down when the gas is withdrawn. Heat is taken from the surroundings via the cylinder coat and used to make the gas boil. The greater of the quantity withdrawn from the gas cylinder, the greater the requirement of the heat energy. The LPG cools quickly and draws more and more heat from the environment. This first causes the formation of condensation at the side of the cylinder. If the connected gas appliance continues to draw so much gas, the temperature in the LPG drops below 0 degrees Celsius, and so does the outer wall of the cylinder. The water transforms into ice crust. At the same point, the gas can no longer evaporate in the volumes required. As a consequence to this, hardly any gas or no gas whatsoever can be drawn to the appliance. If you wish to prevent icing, you should always balance the output of the connected gas equipment with the withdrawal volume of the gas cylinders. Now let's have a look how we're going to size these LPG cylinders and bulk storage tanks so we know we've got the correct amount of gas going to the appliances. First thing to note is we're going to be using the calorific value of 95 megajoules per meters cubed. Everybody seems to use that as an average. So the appliances we've got are a 30 kilowatt boiler, we've got a 10 kilowatt cooker, and we've got a 7 kilowatt inset live fuel effect fire. That gives us a total of 47 kilowatts. Now what we need to do with those 47 kilowatts is turn it into megajoules, so we times it by 3.6 because there are 3.6 megajoules in a kilowatt, just like there is in natural gas, and that equals 169.2 megajoules. We then take this 169.2 and we divide it by 95 megajoules because that's our calorific value of gas, and that comes out at 1.781 meters cubed an hour. So that's how much gas we need to provide for all these appliances. If we take a standard 47 kilowatt propane cylinder, it gives us 1.27 meters cubed an hour takeoff rate. So if we try to connect all these to one cylinder, then there's every chance it's going to freeze up because it's going to take up too much gas off. So it's going to be drawing the liquid in. So what we have to do is take the 1.781 megajoules and we need to divide it by 1.27, because remember that's our takeoff rate for a 47 kilogram propane cylinder, and we get 1.40 cylinders. So we need just under 1.5 cylinders. So what we would have to do is link 2 cylinders together. Best practice would be 4 cylinders on a automatic changeover valve, so you've got 2 running at once. When they run out, then you swap over to the other 2. Or the best practice would be bulk storage. So the smallest bulk storage tank we can get gives 380 litres, which gives us a takeoff rate of 2.3 meters cubed an hour. So that's giving us way more than we need, so we wouldn't have to change the gas over as much as we would do with the cylinders. So that's how we size cylinders and bulk storage tanks. So that's the end of part 1 on this look at LPG training. Don't forget, if you want a training manual to go along with these videos, why don't you check out the Viper Gas? And hopefully you've liked the video, and I'll catch you on part 2, I guess. Cheers.